Hi, our presentation will be on the design and development of field cladding test facility for small mesoscale specimens. Zircaloy field cladding purposes as a barrier to prevent fission products into the environment. Zircaloy material is chosen for its high resistance to heat and corrosion as well as its low neutron absorption. Since the cladding is internally pressurized, it is important to measure its mechanical properties triaxially to ensure its structural integrity in use. Our capstone project is in collaboration with Canadian Nuclear Laboratories, and they plan to use the finalized design in their lab research for nuclear fuel cladding.
Our simulations help identify the best testing setup in order to determine the cladding mechanical properties in different conditions and points in its lifetime. Knowing these properties allows for changes to be made to the cladding and environment that can extend the useful lifetime of the cladding. Increasing the lifetime reduces the amount of cladding that is made, including the mining of heavy minerals, the land impact of which can be seen in the top right of this slide. It also reduces the amount of spent cladding that has to be specially stored since it's radioactive. The storage mechanism is shown on the bottom right and is costly and long-term.
The overall goal of our project is to design a testing apparatus to determine the mechanical properties of cladding in the radial direction, which is done using the ring hoop tension test and ring compression test.
To determine the transverse mechanical properties of nuclear field claddings, the two most common test methods used in industry are the ring hoop tension test and the ring compression test, which complement each other in terms of the extraction of mechanical properties. The ring hoop tension test applies a load from the inside of the sample, while the ring compression test applies a load external to the sample via a movable upper plate. For this project, we're using small samples of around 5 millimeters diameter, which in the case of the ring hoop tension test are varied in terms of the number of gauges, the gauge orientation, and the gauge length to width ratio. For the ring hoop tension test, we're also investigating two grip designs, the 2-piece grips, which are shown in the drawing on the left, and the 3-piece grips, which are shown in the drawing to the right.
In order to assess the best combination of specimen orientation, and grip type, we've designed 8 scenarios which are shown here. For the 3-piece grips, 3 different cases were trialed to determine the best combination of fixed, floating, and moving parts in the grip. The best results from those 8 scenarios are shown here. The top results include the 2-piece grip, which has a specimen gauge at 0 degrees to the loading axis, and the 3-piece grip with the specimen gauge oriented 90 degrees to the loading direction. This corresponds to scenario 3 from the table before.
Using a Zircaloy plasticity model, we created a ring compression simulation to observe the deformation and 3-thickness stress development on cladding and compression. The deformation progression shown here was in line with that which we have seen in our literature review. We expanded this model to investigate the mechanical effects of accident-resistant coating on the performance of cladding material. A 60-micron coating of chromium was modeled on the Zircaloy specimen. For this model, we observed the strength difference of coated and uncoated samples in the elastic region, with no significant strength increase being found.
Our final recommendation for optimal testing is a double gauge specimen with a 3:2 length to width ratio at 0 degrees orientation for the 2-piece grip and 9 degrees for the 3-piece grip, with a fixed center and moving upper and lower pieces. Both the 2 and 3-piece grips can be used for optimal results, but the 2-piece grip gives slightly less bending outside the gauge section. For the ring compression test, the accident-tolerant coating has little effect on the mechanical strength, though the coating does limit oxidation and can improve creep resistance. Thank you for listening.